Alright, so welcome to your first database section of the Full Stack Web Development course. We're going to start out with one of the most popular types of database management systems, and that's MySQL. So MySQL is an open source relational database system, and it's one of, if not the most popular of its kind. Now, a lot of what we do and talk about in this section is going to pertain to most relational SQL-based databases. For instance, in the next section, we'll be looking at Postgres, which is also a relational database. So a lot of what we learn in this section can be used in that one as well. All right, MySQL can be used with many different programming languages. We've already used it with PHP back in the PHP section, but it can also be used with languages like Ruby, C, C++, Python, and many more. Now, like with most relational databases, the data or the records are stored in a table, and a table is made up of columns and rows. It's almost identical to a spreadsheet in terms of what it looks like. We have columns at the top and then rows of data in those columns. MySQL obviously uses the SQL language, which stands for Structured Query Language. And this is a language that's dedicated to working with databases. All right, I'm not going to talk too much about that right now because we do have a lecture that's dedicated to the SQL language. All right, so let's take a look at some of the advantages of working with MySQL. So MySQL offers high performance, and it uses a unique storage architecture that allows databases to be configured for specific applications, which gives us better performance results. Okay, it uses memory caches, full text indexes, and other performance enhancing solutions. It also has high availability and data integrity to minimize any downtime. There's also additional solutions that can be used like MySQL cluster and MySQL replication to even further reliability and availability. MySQL also offers security features that can ensure absolute data protection. Only authorized users get access to certain databases. SSH and SSL are supported, and many other security features. Ease of use is another great advantage. Like I said, MySQL is the system that most developers learn how relational databases work, at least in my experience. It's really simple to get up and running, and it also has a really clean syntax. There's also great support and documentation available. MySQL.com has a ton of examples, tutorials, and support available. There's also a huge community of developers and administrators that are willing to help anyone that asks. Okay, many different forums across the internet. And finally, MySQL is open source and free. Okay, a lot of corporations are hesitant when it comes to releasing open source software, but MySQL is able to do so and still provide great support. All right, so there's a couple small disadvantages of MySQL. It does have some minor stability issues. According to DigitalOcean, MySQL tends to be a little less reliable than some of its peers. The issues mostly pertain to references, transactions, and auditing. So any projects that will use these features should just look into it a little more. The next one is scalability, and this isn't really unique to MySQL. It's relational databases in general. It can be kind of challenging to scale past a certain point. Some other types of databases like NoSQL are much easier to scale. Deployment has also been a bit laggy compared to other systems. This has been mostly since Oracle purchased it from Sun Microsystems. There's only been one major release in the past several years or so. And then finally, there's some limitations with MySQL. Like any software or technology, it's not built for every situation imaginable. It's not fully SQL compliant, and there can be some limitation in areas like data warehousing and fault tolerance. So the requirements for MySQL, it is cross-platform, and you can use it with Linux, Unix, Solaris, Windows, Apple. CPU recommendation is at least a dual core, 2.0 gigahertz or better. 20 gigabytes of hard drive space plus, and then at least 2 gigabytes of RAM. All right, so you can run MySQL on a very, very low-end system. All right, obviously it's not going to give you, great performance, but you can in fact run it on older, low-end machines. All right, so there's a ton of MySQL tools available. Of course, it has its own client, its own command line interface. PHPMyAdmin is one we'll be using. That is a web-based GUI. We can create tables, run queries, pretty much do anything, and you can do it within a GUI. It's not command line based. MySQL Workbench is another one. I've used that quite a bit. Nice diagramming capabilities. SQL Pro, Heidi SQL, and MyDB Studio are some other ones. I haven't used these personally, but I have heard good things about them. And there's a lot more as well. Alright, so that's a very brief introduction to MySQL. In the next video, I want to talk more about SQL itself, structured query language. We'll take a look at some examples, and then we'll move on to install MySQL, and we'll start to work with some queries and different clauses and so on. Alright, so I will see you in the next video. Alright, so we briefly looked at MySQL and what it is, some of the advantages, disadvantages. Now we're going to look more at the structured query language that MySQL runs on. So SQL, as I said, stands for Structured Query Language, and it's a programming language that was designed to manage stored data in a relational database management system. Okay, SQL is defined as declarative programming. It uses the declarative paradigm, which is basically a language that uses code to express the logic of computations without describing its control flow. It also has some elements of procedural programming using procedures and routines. SQL is not something that only works with MySQL or was built for MySQL. There's actually many database systems that support SQL, such as Postgres, which we'll also be looking at in this course. All right, SQL is based on relational algebra and tuple relational calculus. And as far as its scope, it includes data insert, query, update, and delete. Okay, it has a ton of different expressions and operators, which we'll be looking at throughout this section. So some of the language elements, we have clauses, which are constituent components of statements and queries, and these are sometimes optional. So something like a where clause. Expressions, which can produce scalar values or tables consisting of columns and rows. Predicates, which specify conditions that can be evaluated to true, false, or unknown, and are also used to limit the effects of some statements and queries or to change program flow. Then we have queries, which are used to retrieve data based on a specific criteria. And then a statement is all of this together, which may have a persistent effect on the database schema or may control program flow, connections, sessions, or diagnostics. So here's an example, a labeled example of a statement. So here we have the update clause. We're saying we want to update the table country. And then here we have a set clause. We want to set the population equal to this expression, which is population plus 1. Okay, that's considered an expression. Then we have our where clause. We're saying where name, where the column name is equal to the string of USA, which is considered an expression. All right, so this part here is considered the predicate, and then all of it is a statement. Okay, so that's an example from the MySQL documentation. All right, so when we create our tables, we can define a primary key constraint. So this will uniquely identify each record. Okay, primary keys must contain unique values and they cannot contain null values. Most tables should have a primary key, although they're not required, especially if you have some kind of junction table or relationship table. They're not required. And then one table can only have one primary key. All right, you can have multiple foreign keys, which we'll get to later on, but only one primary. Now we can also set a field to be auto increment, and this allows a unique number to be generated when a new record is inserted into a table. So for instance, let's say we have a table and the very last record that was inserted has an ID of 5. Well, if we go and we insert another record, it'll automatically be 6, okay, and then 7, 8, and so on. And this is only if the field is set to be auto increment. All right, and this is usually added to the ID field of a table, but of course you could call it anything you want. It doesn't have to be called ID. All right, and it'll increment by 1 by default. And you don't need to specify an ID when you do your inserts. Okay, so that's a really nice advantage, is you don't have to worry about creating an ID. All right, we can also set a default constraint, and this is used to insert a default value into a column when it's created, and this will be added to new records. So in this example here, we're creating a table called test with an ID and a city field, and we set for city a default of New York. So that means that when we insert a record, if we don't specify what we want the city to be, it'll be New York. That'll be the default. All right, and you can also set a timestamp as a default as well, which is really nice if you want to get the date and time of when the data was inserted without having to actually define it in your code. All right, so let's take a look at some common operations and queries. These are just the most used. We have select, which will fetch records, and this has no persistent effect on the database. It's not going to change anything. It's just used to grab the records and display them. Insert will obviously insert new records. Update will update records that already exist in the table or in the column, and then delete will delete records. All right, and then we have some common clauses and operators, such as where, which will limit rows returned by a condition. All right, so we can specify, for instance, select name where ID equals 5. So then it will return the name of the record that has the ID of 5. Join will combine rows from 2 or more tables. Like is used in a where clause to search for a specific pattern. Okay, this is used in searching, for instance. In will allow us to specify multiple values in a where clause, and then between will select values within a range. All right, so in the next video we're going to install MySQL. I'm going to give you a couple different ways to use it, to install it, and then we'll move on to start to use SQL and write some queries and work with our database. Alright guys, so there's a lot of different ways that we can get MySQL up and running on multiple platforms. We happen to be in Windows, and we could use the MySQL installer from the official MySQL website, but I want to install Xampp or Xampp, and we actually did this back in the PHP section if you've been following along. Xampp gives us an Apache server, PHP, and MySQL. Okay, technically it's MariaDB, but it's a drop-in for MySQL, so everything is the exact same. It's fully backward compatible. And it also gives us PHPMyAdmin, which is a really nice web-based GUI tool that allows us to interact with our database visually through a GUI, through a graphical user interface, but also gives us a command line option, which is mostly what we'll be working in, because the goal is to learn SQL. So I think that's a better option than to just work in the command line, so that's what we're going to do. You want to go to apachefriends.org, and we're going to download for Windows. Okay, I'm actually not going to save it because I already have it downloaded, so just download that and then open it up. Alright, you might get this this warning about your user access control system and some conflicts, but I've never actually seen any issues with that. So we're just going to click OK and then go through the installer. Now there's a few different components that we don't need here, so we're going to keep Apache and MySQL. I'm going to uncheck FileZilla, Mercury, and Tomcat. And then I'm also going to uncheck Webalizer and Fake SendMail. Okay, we don't need those, so we'll click Next. C drive, Xampp folder, that's fine. And click Next again. It's just going to open up this bitnami.com website. We can just close that out and then click Next. And it should go to proceed to install. Alright, so that's all set. Now it's going to ask if we want to start the control panel. I'm going to uncheck that and click Finish. And the reason I didn't start it up there is because we want to run it as an administrator. So if we go to the C drive or wherever you installed Xampp, and then just go to this Xampp control exe and then click Run as Administrator. Alright, so you should get something like this. Alright, now we could start it from here, but before we do that, I just want to install it as a service. So we're going to click this red X, and if you can't click this X, that means that you didn't run this as administrator, so make sure you do that. Alright, we'll also install MySQL as a service, and let's start up Apache, start up MySQL, and we should be all set. Alright, so let's see if we can go to localhost/phpMyAdmin. And there we go. Alright. Now notice down here we're getting an error message, or a warning at least, that says we're connected as root with no password. So we want to fix that. We want to add a password to our root account. So if we go to user accounts and then go to let's see, where it says root and localhost, see how it says no password? We want to edit privileges and then click on change password and then just add in a password here. Alright, then we'll click go, and now when we try to go back, we're going to get booted out. Alright, so to fix this, what we need to do is go to our C drive. Let's see, C drive and Xampp, and then phpMyAdmin, and then there's a config file, which is right here, config inc php. So we're going to go ahead and open that up. Alright, now in this file, if we go down to right here where it says password, you'll see it's blank. You just want to put in the password that you just created. Alright, so we'll save that, and let's go back and reload, and now everything's all set. Okay, we can now get in. Alright, so in the next video we're going to start on SQL. Now we can easily create databases from here, and we can add tables easily through this interface, which I'll get to later, but what's important is that you learn how to actually write out queries and stuff. So we can use this command line interface here to do that. Alright, so I will see you in the next video. Alright guys, so now we're going to start to work on our database. So we're going to build an online store database. We're not going to focus on the front-end application or programming or anything like that. We just want to build the structure, the data structure. Alright, so we're using phpMyAdmin, which is a graphical tool, and we can easily create tables and fields and stuff through the graphical user interface, but I want to get you familiar with SQL, so that's what we'll mostly be dealing with, is SQL commands. So if we click on the SQL tab right here, it'll take us to command window, and in here we're going to say create database, and we're just going to call this, we'll call it my store. Alright, and let's make this a little bigger, and I'll go ahead and click go. Okay, so it gives us a success message, and now over here you can see we have my store. Now all the commands that I'm running you could just as well run inside the MySQL shell or any other client really. Alright, so the platform, the phpMyAdmin system we're using is irrelevant when we're talking about SQL commands. You could run these from anywhere. All right, so let's go back. Actually, let's click on the MyStore database. That way we're actually using that particular database, and then click on SQL in our menu here. All right, so you can see we're in that current database. Now, first thing we're going to do in this database is create a customers table. So we'll say create table, and this doesn't have to be in caps. It's just preference. I like to keep my statements in uppercase. All right, so but it's not required. So let's create a customers database. Table. Now inside here we want to create all of our fields. So let's say we want an ID. That's going to be an int. And let's say it's going to be not null. And we also want this to be auto increment. We want it to increase or increment as we enter records. Okay, so to do that, we can say auto underscore increment. You can see there's a little code drop down here that we can select from. All right, in addition to the ID, let's do first name. And now as far as your formatting for your field names or your column names, you can use underscore like this. Some people will use the camel case like this, or even uppercase in the beginning as well. But we're going to stick to the underscore method. Okay, so we'll say every time there's more than one word, we're going to separate it with an underscore. All right, so first name, that's going to be a variable character or a varchar, and then we just want to say that the max for this will be 255. All right, and let's just copy that. All right, so let's make this one last name. Okay, then we'll do email. What else? Let's do, we would probably have a password if this is an online store. Okay, let's also do an address or street address. Okay, we'll add a couple more here. So street address, then we'll do city, state, and zip code. Okay, so that looks good. Now we want to let the system know which one of these we want to be our primary key, and we want the ID to be the primary key. So down here, let's add on primary key, and we want to say ID. All right, so that should do it. Let's go ahead and click go, and looks like it went okay. And if we look in my store, you can see we have a customers table. If we click on that, there's no data in the table, but if we click structure, you can see all of our fields. All right, and everything is a varchar aside from the ID. Okay, and you can see the ID has a little key next to it telling us it's the primary key, and it's also auto increment. So now what we want to do is we want to insert some data into these fields. All right, so let's go back to our SQL tab here. Now notice we have this columns thing right here with all the different fields, and it pre-filled this with a select statement. That's because right now we're in the command line window, but we're also inside of the customers table. All right, that's why we're seeing this format. I actually don't want to be inside of a certain table, so let's click on this database MyStore and then click SQL, and now we're just in the general database, not inside of a specific table. So now we want to do an insert. So we're going to say insert into, and then the name of the table we want to use, in this case customers, and then inside our parentheses here we need to specify the fields that we want to add, data to. So let's say first name, last name, email, what else? Password. Let me just open this up in another window. Oh no, I can see them right here. All right, so we got first name, last name, email, password, street address, city, state, and zip. I think that's everything. All right, now notice that I'm not putting the ID, because the ID is auto increment, so that's going to get inserted automatically. Now, what we want to do is go outside of our parentheses and then say values, and then open another set of parentheses, and we want to insert the data that we want. All right, so we're going to go in the same order that we did here. All right, so let's go and let's say first name, we'll do, I'll just put my name. Okay, first name, last name, email, password. Normally you would have your whatever programming language you're using, you would have that encrypt your password so that it's not a plain text password like this, but we're not going to worry about that now. Okay, street address, we'll say 20 Main Street. This isn't my actual address, by the way. City, we'll say Boston, Mass, and then the zip code, we'll say 01294. Alright, so let me just make sure that this matches, it's in the correct order. Alright, and notice I have quotes around these because they're all strings. They're all text strings. So let's put a semicolon there and we'll click go. Okay, so it says one row inserted. And now if I click on database my store and then click on customers, you can see that our record is now in the database. All right, and we could edit it from here if we want, and we can do all kinds of things through the GUI, but we're not going to do that. We're going to just stick to the command line or the SQL queries. Now we can also insert multiple records in one query. If we go to SQL, and this is pretty long, so I'm going to paste it in. Alright, so you can see here we have 6 more customers, and all we did was we specified insert into customers, all the fields, and then values, and then we just have some parentheses with all our fields, and we just separated these with a comma. Alright, so let's go ahead and click go. And now if we go to our customers table, you can see we have all these different customers added. Alright, so in the next video we're going to look at ways that we can query this data. Alright guys, in the last video we went ahead and created a database, a table, and added some data. So now we're going to go ahead and we're going to run some select queries. Alright, so let's go to SQL, and for now let's just do select, and we're going to use this asterisk here, and this represents everything. So we want to select everything from, and then we want to put in the table name. So let's say customers, and let's end that with a semicolon and click go, and now you can see it's doing just that. It's getting everything. It's getting all the data, all the rows, and returning it back to us. Alright, and this is why I wanted to use PHPMyAdmin, because you can see our result is very clear. We can see all the different fields and all the data, alright, rather than in a little command line window. So that's selecting all from customers. So let's go back. Now, in addition to selecting all, of course, we can specify what we want to select. So if we say select first name, last name from customers, and we click go, now you can see we get our results, but we're only getting the first name and the last name. Okay, we're not getting any of the other data. Now, up until this point, we have been getting everything, all the data, whether we're just getting some of the columns or all of them. So what if we want to limit it to a certain condition? All right, so let's go back and let's do, we'll say select all from customers. Now, if we want to specify a condition, we can use the where clause. Okay, so we'll say where, and let's say we want where state equals MA. All right, so let's try to run that, and we're getting an error, and that's because I think this needs to have quotes like that. Okay, so now it's giving us the customers that live in Mass. You can see I had two of them from New York, and those ones aren't coming up. All right, and just as well, if we wanted to search for, let's say, a specific user with a specific ID, then we could say select all from customers where ID is equal to 2. All right, and now you can see that's only giving me John Doe because his ID is 2. Now we can use other operators aside from the equals. For instance, let's say we want select all from customers, and we'll say where ID is greater than 3. Okay, so instead of equals, we can use the greater than operator. Click go, and you can see we get everybody with an ID 4 and higher. All right, and that's particularly useful with things like money. If you have transactions with balances, things like that, that can come in really handy. All right, and just to quickly show you some of the different operators, let me bring this in. All right, so this is from w3schools.com, and you can see we have equals. We can use not equal, so this less than, greater than, less than. We can also do greater than or equal, less than or equal. And then we have these three here. We have between, which is between an inclusive range, like, which we can search for a pattern, and then in, which allows us to specify multiple possible values for a column. All right, so let's take a look at these three here. So we'll go back to our SQL window, and we'll say select, let's say we want the email from customers, and we'll say where ID is between 2 and 4. All right, so let's see what that gets us. Actually, we'll get the ID as well. All right, so let's go ahead and click go. And there we go. So we have customers with the ID of 2, 3, and 4. All right, so that's between. Now let's take a look at like. Let's actually take a look at the data real quick. All right, so let's say we want to get all the cities that start with the letter B, or we want to get data from everyone that lives in the city that starts with the letter B. All right, so let's go and say select all from customers, and then we'll say where, let's see, where city like, and then inside quotes we're going to say B, and then percent symbol. All right, actually let's make that an uppercase B. So click go, and now you can see we get everybody, Boston and Brooklyn. Okay, so those are the cities that start with B. So you can do patterns. It doesn't have to just be one letter. Okay, it could be anything. So let's say, we'll say select all from customers where city like, and let's say BO %. Okay, the percent is the wild card. So we're saying where it's BO anything. Okay, percent can be anything. And you can have a percent on both sides as well. All right, so let me just copy that. So I have to type it back out. And then we'll click go. And now you can see we're only getting from Boston because it's BO. Okay, Brooklyn would be BR. All right, so if we say, let's put a percent and then an O and then another percent, this is going to get cities that just basically that have an O, okay, no matter what is before or after it. All right, and you can see Boston and Brooklyn is what we're getting. Okay, so that's like. Now we also have in, and what in does is it allows you to easily have multiple values in your where clause. Now we could do this without in. Let me show you that way first. So if we say select all from customers where, and let's say where city is equal to Amesbury, and then we're going to say or city is equal to Salisbury. Okay, so let me just copy that and then we'll run it. And now you can see we're getting all the records who are in either Salisbury or Amesbury. Now this is fine if we're just searching for 2 cities, but imagine that we're searching for, let's say, 10 cities or 20 cities. All right, so that will get quite long. So let's go back and paste that in. All right, so we'd have where city equals something or city equals something and so on. So in allows us to shorten that. So instead of doing all of that, we can say where city in, and then open up a set of parentheses, and we'll say Amesbury, Salisbury, and you could just keep going on. All right, so if we run that, we get the same result. All right, so we're going to go ahead and stop here, and we will continue in the next video. All right, guys, we're going to get into multiple tables and joins soon. I just want to touch on something real quick. So I want to look at distinct, I want to look at aliases, and concat. Okay, these 3 things, and this will be really quick. All right, so we're going to go to our SQL window here. And what distinct does is it does just that. It returns a set of distinct values. So if I were to say select city from customers, and we ran that, it's going to give us just each record, just the city. But you can see that we get repeating values here. Salisbury twice, Boston twice. So to get just a list of cities with no repeats, we can just add in here. Whoops, I don't want to do that. We can just say select distinct city from customers. Okay, so if we go ahead and run that, it's just going to give us each city once. All right, so that can be kind of useful. Now we also have aliases, which allow us to basically format the returned column names in a nicer way. All right, we can also use aliases within our queries. So let's say we want the first underscore name to be formatted a little nicer. So we can use this as keyword, and then we could just say first name or something like that. But if you want to use a space, which I do, I want to format it like that. You can see that we're getting an error now. If we want to use spaces, then we can just use quotes around it like that. All right, so we'll take first underscore name as first name, and then last underscore name as last name from customers. Okay, we'll run that, and now you can see that the column names are formatted nice and neat. Alright, now we also have Concat, which allows us to basically combine columns. So if we say select Concat, and in here we'll say first name, put a comma here, and then let's put a space, and then last name, and let's make that as name. Actually, I'm going to put that in quotes, as name. Alright, and then we'll do another concat, and let's say street address, then we'll do that, and then city, and state, and we'll do that as address. Okay, and then we'll say from customers. Alright, so let's see what that gives us. So now if we go down here, you can see that we have just two columns here. We have name, which concats the last name to the first name, and then address, which concatenates the street address, the city, and the state. Okay, so we can easily combine different results like this, different columns. Alright, so I just wanted to touch on those things before we move on to joins. Alright guys, in this video we're going to look at updating, deleting, and also altering tables with alter table. So first thing we'll do is update. Okay, so in our customers, let's say we had someone get married. Let's say that Janet got married. Her last name is no longer Thompson. Let's say she married Kevin, so she's going to be Janet Smith. So we need to update that record. Alright, so let's go to our database, MyStore, and then SQL. And we're going to say update, and then the name of the table. So update customers. And let's actually go on the next line, and we're going to say set last name equals Smith. And we could put a comma here, and we could edit other fields as well, but we just want to update the last name. And then down here, we'll just use a where clause. And we'll say where ID equals, and let me see, I forget what ID she was. She's ID 4. Alright, so where ID equals 4. Alright, so update, name of the table, set. You want to set the fields you want to set, and then add the where clause. So let's click go. Alright, and then we'll go back to our customers, and now you can see that Janet is now Janet Smith. Alright, so pretty simple. Now let's say that Stephanie is no longer a customer, so we want to delete her. She has an ID of 7. So let's go to our SQL window, and we're going to say delete from customers where ID is equal to 7, and that's it. Click go. Now if we go back to our customers, you can see that the customer with the ID of 7 is now gone. Now what if we wanted to add a column to an already existing table? So let's say for instance in customers we want to add a balance field, okay, or a balance column. So let's go to our SQL, and we're going to say alter table customers, and then we'll say add, and then the column name, so let's call it balance, and then the data type. Okay, so we'll say varchar 255. Alright, let's go ahead and run that. Okay, successful. So now if we go and we look in customers, you can see we now have a column called balance, and anything that's in it currently is going to be null because we haven't added anything to any of the balance column. All right, it's just all null. So if we want to remove a column, we can easily do that too. It's actually going to be the same thing, except instead of add, it'll be remove. So alter table, customers, and then you would say remove, and then the table name of balance. All right, but I'm actually going to keep balance. So I'm not going to actually run it, but what I do want to do is change the data type. I set it as a varchar, but I actually want to set it to a float. So instead of add or remove, we're going to say modify column, and then the column name, which is balance, and then the data type, which we want as float. So let's click go, and let's take a look. Okay, it's still null, but if we click structure, you'll see balance is now a float. Okay, so that's how you can alter tables or alter columns. Now let's say we want to add a balance for somebody. So we'll say update customers, and we'll say set balance equals 500 where ID equals 1. Okay, let's take a look at that. And now you can see the user with 1 has a balance of 500. Alright, so that's how we can update, delete, and alter tables. Alright guys, so we've been working with one table so far, which is the customers table. Now we're going to create a couple more. Okay, so this is a store, so we need to have a products table. So let's go ahead and do that. Okay, so we'll go to our SQL window here, and let's say create table products, and we'll open up some parentheses here, and inside here we want our fields. So we're going to have an ID, which will be an int. It's going to be not null, and we also want it to be auto increment. Okay, we'll also have a name excuse me, a name for the product, which will be a varchar of 255 max. It'll have a price, and price is going to be an int. Alright, and that's what we'll do for fields. Now we want the primary key to be the ID. Alright, so we're going to go ahead and run that. And if we look at our database now, you can see we have a products table. Now let's insert a couple products. So in our SQL window, we'll say insert into products. And we want to define the fields we want to insert into, so name and price. Okay, then we'll say values. So for the first product, we'll just call it product 1. And then for the price, let's say 10. Alright, so if we run that, that should put a product into the table. Alright, so let's go back. Now I'm going to just paste this in. We're just going to add a couple more, product 2, 3, 4, and 5, and we'll click go. And now we have a bunch of products in the products table. Now we're going to create a third table called orders, and that's going to hold the customer ID, and it's going to hold the product ID. Okay, so let's go to our SQL and we'll say create table orders. Alright, and in here let's say we want an ID. That's going to be auto increment, ID int not null. Okay, then we're going to have the order number, which will be an int. Why does it keeps adding the O? Okay, order number, which is an integer. Then we're going to have the product ID, which will be an int. Okay, then we'll have the customer ID. Then let's do the order date. Okay, the order date will be a date time field. All right, and let's say we want the primary key to be ID. All right, now the product ID and the customer ID, these are going to be foreign constraints or foreign keys. And what that means is that the product, this field is going to pertain to the primary key of the products table, which is ID. This will be to the primary key of the customers table, which is ID. All right, so let's define these as foreign keys. So down here, and we're going to do this just like we did the primary key. We're going to say foreign key, and we're going to add in the field name, which will be customer underscore ID. Now, in addition to that, we have to let it know which table and which field this pertains to. So we do that with references. So we're going to say references, and then this is in the customers table, and it's going to be the ID field. All right, so that's how you can define a foreign key. Now I'm going to copy that, and we're going to do the same thing for the product ID. And that's going to be the products table and the ID field. All right, now the last thing we want to do is this order date. I don't want to have to manually put that in. I want it to have a default of the current timestamp. So what we can do is just add on default and then current timestamp. All right, and that'll do it automatically for us. So let's go ahead and run that. All right, and if we check it out, you can see now we have a table called orders. Okay, and it has all those fields we just created. Now you can see the little gray key here. That's telling us that these are foreign key fields. Now foreign keys prevent data corruption. And what I mean by that is if we have in orders, if we have a record and it has a product ID foreign key of 3, that pertains to the products table ID of 3. All right, now if we were to delete that product from the products table, and then we have this linking to that product that's not there, that's going to cause a problem. All right, so what this does is it makes it so that we're not allowed to delete something if it has a foreign key somewhere else. Okay, so if we have an order that pertains to that product or that customer, then we don't want to be able to delete that product or customer unless we delete this first, the order first. All right, so hopefully that makes sense. So let's go ahead and add some orders. All right, so we have some customers, so we'll pick one of these, and then we have some products. So we want to mimic these customers buying a product. So let's go to our SQL window, and let's say insert into orders. Okay, and in here, let's say ID. ID. What other fields did we have here? Order number. Then we have customer ID and product ID. And actually I think that's it, because the order date will automatically be put in. All right, so after that we're going to say values Okay, so actually the ID we don't need to do because that's auto increment. So order number, which I believe is an int, so let's just say 001. And then customer ID, we'll take the first customer, and then we'll take the first product. Alright, so let's click go, and then if we go and we visit the orders table, you can see that we have the order number, which it just put 1. Actually, you know what, we don't really need the order number, but we'll just keep it. I did do 001. Since this is an int, it's going to trim off the leading zeros. Alright, we'll just leave that for now. So just looking at this table, we don't get that much information from it. Alright, we can't see the customer's name, we can't see the product name. It's just some IDs. Alright, so this by itself isn't very helpful, but when we use it in a join statement, we can use it to grab information from both tables, the products and the customers. And that's what we'll be doing in the next video. Alright, and I just quickly want to add a couple more orders. So I'm going to go in here and paste it in. Alright, so we're just adding in the order number, which is just 2, and then we're adding 1 to it, and then the customer ID and the product ID. Okay, so we'll go ahead and run that. And now we have a bunch of orders. Okay, so in the next video, I'll show you how to write join statements. Alright guys, so our online store database now has products, customers, and it has some orders which links the customer to the product that they purchased. So what we want to do now is we want to be able to query orders. But if we were to query just the orders table, this is the data that we'd get, which isn't very helpful. Alright, so we want to be able to get, for instance, the customer's name along with the product title or the product name, not just the ID, because that doesn't tell us anything. Okay, so what we can do is we can write join statements. Okay, joins are used to combine rows from either 2 or more tables based on a common field between them. Alright, so in most cases it's going to be between the primary key of one field of one table and the foreign key of another. So there are different types of joins. Okay, so we have inner joins, left joins, right joins, and full joins. Let me just open up a page from w3schools.com, and this gives you a good explanation. Alright, so an inner join returns all rows when there's at least one match in both tables. Alright, a left join, and that's the most common, a left join returns all rows from the left table and the match rows from the right table. Okay, the right join will return all rows from the right table and the match rows from the left table, so it's the opposite. And then a full join will return all rows when there is a match in one of the tables. Alright, and you can read more about this here, and there's some other good articles too if you just do a search for inner join versus right join or left join. Alright, so let's go ahead and open up our SQL window, and we're going to write a very simple inner join. So let's say select, and we want to say select customers dot first name, and let's get customers dot last name, and notice that I'm using the actual table name. Alright, and I'm doing that because you may have some cases where you have a column name that is a duplicate between tables. So you might have a product name, and then you might have a customer name, and they're both called name. So you can easily make the distinction by using the table name and then dot and whatever the column. Alright, so we want the first name and last name from the customers table. We also want the orders dot ID, and let's get orders dot order number. Alright, and we're going to say from customers. Okay, so right now it's only from the customers table. Then what we want to do is we want to join in the orders table using an inner join. So we'll say inner join orders. Okay, now what we need to do is tell it which fields to match. So we do that with on, and then we'll say customers.id equals orders.customer ID. So we're matching them by these fields here. All right, so let's go ahead and let's copy it, and then we're going to run it. Okay, so we're getting an error, unknown. Oh, this should be order underscore number. Okay, so now we're getting the first name and last name, and we're getting the ID of the order and the order number. Okay, so we're joining those two tables together. And we could probably do without the ID, just get the order number. All right, so let's go back and let's do a left join, and let's do away with the ID, and let's get the order date. So select customers dot first name, last name, and let's do orders dot order number, and orders dot order date. I think that's what it's called. Let me just, yeah, order date. So we want to get this from customers, and then let's do left join orders on customers.id equals orders.customer ID, and then let's do an order by, and we'll do it by the customers.last name. Alright, so let's go ahead and run that. Let's see what's going on here. Oh, I spelled last name. What am I missing here? Order by customers.last name. Oh, we don't want this comma right here. Okay, so now we're getting our first name and last name, and the order is by last name. We're also getting the order numbers, and we're getting the order date. Now with this left join, you can see that we're getting records that don't even have an order number or order date. It's getting all of the customers, even if they don't have an order. All right, so in this situation, an inner join would be the better of the two to use. Now let's see what happens if we do a right join. Let me just fix this. Okay, so we'll just change this to right join. And now you can see that this actually works out better. Okay, just like the inner join, we're not getting customers that didn't order anything. Now another thing you might want to do is bring in the product info. Okay, you might want the product name. So to do that, we can have multiple joins. So let's go to our SQL, and let's paste that in, what I just had. I'm just going to fix this up. All right, so in addition to this stuff, let's add to the end here products.name. Okay, and then we're going to say from, you know what we'll do is we'll say from orders, and then let's go ahead and inner join products. Okay, and we want to do an on right here, so on orders dot product underscore ID equals products dot ID. Alright, and then we're going to do another inner join, and this is going to be the customers. So customers on orders dot customer ID equals customers.id. Okay, and then we'll do order by, and let's do it by the order number. Alright, so let's see what that looks like. Okay, so now you can see that we're getting the first name, last name, the order number, the order date, and we're also getting the product name. So we're joining in two more tables to our orders table. Alright, now we can also use aliases in these statements. So let's paste what we just did in, and let's do select customers.firstname as, actually, you know what we'll do? We'll use Concat as well, just to kind of blend together everything that we've been learning. So we'll say select Concat, and then let's grab this. Okay, and we'll cut that out, and let's paste that in here, and then we're going to put just a space right here. So first name, last name as, let's do as name. Okay, and then let's do right here, we'll say concat, and then we'll take the order number and the order date. For some reason I can't right click and cut, so I'm going to just Control C and then delete it and paste that in here, and let's put a space there, and then we're going to say as order. Okay, and then we want product name. Let's just use an alias here. We'll say product name as product. Alright, so let's go ahead and run that. And now you can see we have the name, which has the first name and last name, the order, which has the order number and the date, and then the product, which has the product name. Alright, so that's how we can use aliases and concat along with our join statements. Alright, so that's going to be it for this video. Hopefully you enjoyed it and learned something from it, and I'll see you in the next. Alright guys, so in the last few videos we created our online store database. Alright, we used SQL queries in the SQL window. Now what I want to do is show you how we can put a database project together using PHPMyAdmin, using the graphical user interface. Alright, and obviously this is a little easier than actually writing out SQL statements, but I figured I could still show you how to do it. Alright, so we are in the databases page of PHPMyAdmin. Alright, so we're going to go ahead and create a new database, and let's call it CD collection. Alright, and we're going to create our first table here, and the first table is going to be genres. Alright, so we'll click go, and we want to have an ID, okay, which will be an integer, and we'll give it a length of 11. We also want to set it to auto increment and primary for the index. So this is the primary key. Alright, and then we'll just have a name field, which will be varchar 255. Alright, so genres will have an ID and a name. So let's click save. Okay, so there we go. We have our genres table. Now let's create another table, and let's call this artists. And I don't know how many fields we'll have. We'll just make it 10. Alright, so artists will have an ID. Length will be 11. Auto increment and primary key. Then let's do name varchar 255. Then let's do a bio, and that'll be a text field. Alright, and I don't know why I did 10 fields, because it's the albums that will have more fields. So ID, name, bio, I think that's okay. So let's go and click save. Okay, so now we have our genres, our artists. Now let's create albums. Okay, for albums, we'll just extend that to 8. Click go. Of course, we'll have an ID. That's going to be auto increment, primary key. And then let's do artist underscore ID int 11. That's going to be the foreign key for the artists. And then we also want genres. So this will be genre underscore ID. Then let's do the name of the album. And let's do a description, which we'll choose text. And let's see what else. Let's do image. And that's basically going to be a URL. It'll point to an image URL. Okay, let's do release date. And let's choose date for that. And I think that should be good for now. So let's click save. Okay, so now we have 3 tables. Now what I want to do is insert some data, and we can do that easily through phpMyAdmin. So we'll start with genres. Let's click on that and then click insert. And then up here, let's say rock, and we'll say hip hop. Let's add a couple more rows here. And we'll say country and dance. See this ignore, I'm just going to uncheck those. Let's see, what do we got? Rock, hip hop, country, dance, and let's say R&B. Okay, we'll click go. Now if we look at our genres, oh, R&B didn't get added. I didn't uncheck ignore, but that's fine. Now for artists, let's click insert. And I have this page open, this officialcharts.com/charts/album chart. And you can see it just gives us the latest albums, and we're just going to use some of these. Alright, so let's say this Green Day right here. So we'll add in here for the artist Green Day. And for the bio, I'm just going to grab some dummy text for that. Okay, so we'll just grab some of this and we'll paste that in here. Okay, who else do we have here? Barry Gibb. Just paste that in. I'll just change it around a little bit. Alright, and let's add a couple more here. We'll say add 5 more rows. It looks like it copied the description. Alright, that's fine. So let's get another artist. Let's see, Craig David. Okay, then let's see, 21 Pilots. Okay, one more. We'll grab Bruce Springsteen. Alright, so let's make sure that these ignores are unchecked. And then we'll click go. And now we have some artists. Okay, and if we want to edit these, we can. Just so they're not all exactly the same. You can double click them here and edit them. Okay, so you can see that using PHPMyAdmin is really easy. You don't need to know any SQL code. So now we have artists. Now let's take some of those artists and add some albums. So Green Day has the ID of 1. And as far as the genre, that's going to be rock. So that's the ID of 1. So let's go to albums and insert artist ID 1, genre 1. Okay, so the name of the album is Revolutionary Radio, it looks like. And if I click buy and then Amazon, it'll take us to show us some more info. Alright, so the name is Revolutionary Radio. Okay, description. Let's see if there's a description here. Alright, so we'll just grab this. Copy it. And then for the image, what we can do is grab it. Can we grab it from here? Maybe not. Okay, so we'll say save image, or not save image, open image in new tab, and then we want to grab this link here. So we'll copy that and we'll paste that in here. And then release date. Release date, I'm just going to make something up. We'll just say October 5th. Alright, so that's a whole album. Let's add another one. So let's say, who do we have? Craig David. So let's grab that. Following my intuition. Okay, so the ID was... let's see, let me just open this up in another tab. So Craig David is ID 3, and then the genre, I think it's R&B, which we don't have. Let's just say dance, which is ID 4. Okay, so artist ID 3, and then genre ID 4. Okay, the name of the album. Alright, and then description, we'll just grab some of this. Okay, and then release date, we'll say October 2nd. And then the image, let's see, can we get in, if we click buy and then iTunes, let's see, can we grab this? Open a new window. Open image in new tab, and we'll just grab this URL. Alright. Okay, we'll paste that in. And let's click go. And now we have 2 albums. Okay? Alright, now one thing we haven't done yet is created our foreign keys. So let's go to albums and structure. And then what we need to do is add an index to these 2 fields where we want the primary key. So let's say index. Okay, do you really want to execute alter table, add index? Yes, we do. Okay, we also want to do it to genre ID. Click OK. And then what we want to do is up here, you see how it says relational view. We're going to click on that. And then here, artist ID. We want to, let's see, we're going to choose artists and then ID. And then for genre ID, we'll choose genres and then ID. Okay, and let's see, that's the internal relation. Down here, we want to add the constraint. Constraint name, we'll say, we'll just say album key, and then column will be, artist key. And you'll see that the only ones that show up here are ID, artist ID, and genre ID. That's because these are the ones that have an index. Alright, so this will be artist ID, and say artists, and then ID. Okay, we want to add another column here, and we'll say genre ID. Actually, you know what? Let's just run this. Oh no, add constraint. That's right. All right, so this will be genre. There we go. All right, so let's click save, and now those should be foreign keys. So let's see, structure, and there we go. So you see the two gray keys telling us it's a foreign key. All right. So now what we'll do is let's do a query here. We're going to use joins so that we can display the album name, the artist name, and the genre name, which are all in different tables. So let's say select, let's say albums.name, artists.name, and genres.name. And we're going to select this from albums. Okay, so we need to get data from the other tables, so let's do inner join. We want to inner join the artist table, and that's going to be on artist.id to album or albums. Let's see, whoops, albums dot artist underscore ID. Okay, and then we'll just copy that, and then this one will be genres. That's going to be on genres.id to albums.genreid. Okay, and then let's just do order by, we'll say albums.release date. Alright, so let's go ahead and run that, and there we go. So we have our album name, the artist name, and the genre name. Okay, now this doesn't look very good with these headings here. They all say name, so we might want to use aliases for that. So let's go back, and I'm just going to paste that in. And let's say select albums.name as album, artist.name as artist, and then genres.name as genre. Okay, so now that looks a little better with the correct headings. Alright, so we have created a CD collection database with 3 tables. And the last thing I want to show you is how to export and import a database through phpMyAdmin. Alright, so make sure you're in the actual database, and then we'll go to export. Okay, and then we can leave everything as is and click go. And then that's going to prompt us to save a file, whatever the database name is, and then .sql. Alright, so I'm going to go ahead and save that to my desktop. Alright, and I'll be including this in your project files. And let's take a look at it real quick. Okay, so I'm going to open it, not with Notepad. We'll just open it with Visual Studio Code. And it has a bunch of info, and these are comments. Okay, this doesn't actually run. And then it can set the SQL mode and the time zone. And then it's going to go and just basically just give us all the queries that we've ran, all right, whether it was manually in the SQL window or through phpMyAdmin. So create tables, albums, we have all the fields. It also adds a couple additional things like the database engine, which is InnoDB, the default character set, things like that. And then this is the insert statement for the albums table. Then we have same thing with the artists, same thing with the genres. Down here is where we added the primary key and the foreign keys. Okay, all the auto increments and so on. All right, now let's say that you have this file and you want to import it into your database. So let's go ahead and create, we'll say testdb, okay, which is now an empty database. And then if we click import and then choose file and go to desktop, and where is it, CD collection SQL, and then click go. Okay, so import has been successfully finished, 22 queries executed. Now if we look at testdb, you'll see that we have all of our tables and we have all of our data. All right, so very simple. And I think we're going to go ahead and stop here, and hopefully you liked this video and you learned something from it, and I'll see you in the next one.